Hey, and welcome back. So, let's start by doing a quick repetition from last time. So, last time we learned that our code starts at the address 0801, and that's the absolute beginning, which means that includes this line of basic code, and that our actual assembly code starts at 0810. Last time I simplified this a little bit. I said that this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes. That's not quite correct. So there are a few more bytes in this basic line. So if you want to read more about that, then I left a link in the previous video, so you can read the details if you're interested. But it doesn't really matter for us. What matters is our starting point of the actual code, and maybe even more important, the start address of our actual assembly code, which is 810. Alright, so enough of that repetition. So let me just remove that. So today we're going to talk about tables in assembly. And we have talked about variables before. And we remember that variables, that's really simple, because one variable, that's really just a memory address. So for every variable we have, that's one address in the memory. So tables, that's basically the same thing, but let me show you how it works. Let me remove this. Alright, so we have our main here. So now I'm gonna make a table. So I just write my table like that and a colon. So just like before, we just make a label. These are labels, as you remember. So that's my table. Now the way you set it up, it's a little up to you, but I find it very easy to do it this way. So remember, if this was a variable, my variable, we just write something like that. The label and a colon, of course, and after the colon, dot byte and a number, the starting number. So that's the variable. Now for a table, as I said, it's almost the same. But a table, that implies that you're going to have more than one space. So a variable, that's just one space, right? We just want to keep track of one thing. But what if we have a list of things that we need to keep track of? So here I'm going to do this, and I'm going to make a table with 5 entries. So I just do it like this. There's my table of 5 entries. So it's basically the same as making a variable, but instead of just writing 1 byte, I write the number of bytes I need for my table. So as you can see, this table has 5 places. So we could do like we did with the variable. We could put numbers in here if we need some starting numbers for this table. But basically it's exactly the same as a variable, which means that this table is going to take up 1, 2, 3, 4, 5 bytes in the Commodore 64 memory. So we just specify, just use the word dot byte and a number for each entry in the table. So it's actually just as simple as that. So let me just demonstrate this. Now, actually, before we get to that, we need to learn something new. So we have looked at LDA, something like that. Something like that. LDA hashtag, which means a number, so we're going to load an A with the number 5. We're going to store A in memory address 2000. This we have seen before, LDA STA. But, as I said, we need to learn something new. So you remember this drawing, right? This was to show you the CPU and the memory, the RAM, and how those two work together. So when we're at LDA with the hashtag and a number, that's loaded into the accumulator in the CPU. When we write STA and a memory address, that value is stored in the specified memory address. So that's the accumulator. LDA, load accumulator. STA, store accumulator. But there are two more registers here. We have the accumulator and we have the X register and the Y register. So those two can also contain a byte, a number, like you see here. So hopefully this picture that we have looked at before isn't too confusing because we're using binary. Remember, we could just as well have written number 5 here or whatever. So it's just a number. So we can have a number in our accumulator, in our X register and our Y register. Alright, so let's take a look at that. So instead of writing LDA hashtag 5 STA and a memory address, I could write LDX, load the X register with a number, let's say 57, and I could store that STX, store whatever is in the X register, store that at memory address 2B9A. That's a very specific memory address, but anyway, you could do something like this. LDX, load X with a number, STX, store whatever's in X in a memory address. So exactly the same like with the accumulator, like we did with LDA STA. You can do exactly the same with the X register. And you can also do it with the Y register. So the Y register, I'm going to load 99 and I'm going to store whatever's in Y in memory address 3000, for example. So we can load something into the accumulator, the X register, and the Y register, and all of those can contain a value at the same time. So right now I could do this without any problem, and inside my CPU now I would have a number 4 in the accumulator, I would have the number 57 in the X register, and I would have the number 99 in the Y register. And of course, since I store the different things, there will also be a copy of that in those memory addresses. Alright, well, this is if you feel that you can't really put everything together because it's so technical, you can't really see how this could be applied to making a game, then please just hang in there, because eventually things are going to make sense. But first we need to nail the basics here. So right now let's just focus on creating a table. So let me remove this one and let's just focus on the X and Y register. So why am I talking about X and Y registers? Well, when working with tables, we could run this code, and this table would be put in the memory of the Commodore 64. But it's no good just having a table thrown in there. We need to make something happen. So what I'm going to do now, I'm going to, you remember that we stored a number in a certain memory address, and that made the border color change. And that memory address was D020. So I'm going to do that with my table. So I'm going to do this. I'm going to load X with a hashtag and a 0. I'm going to load X with a 0. Then I'm going to load A with my table, comma X. So what's happening here? Well, first I'm loading the actual number 0 into the X register. Then I'm loading something into the accumulator. What am I loading? Well, I'm loading my table, but comma X. That means that the X register is going to be an offset for us. So if we say that the X is 0, then we're going to get the very first value. If I loaded the X with a 1 here, then load A my table comma X would be this value. And then load X with 2 and do this, then it would be 0, 1, 2. So we will get this value. So let's try that. Let's start by loading X with 0. And now, after loading X with 0, I load the accumulator with my table comma X. And right now, there's a 0 in X. So I'm gonna store the whatever is in that table position. I'm gonna store that into D020. And as I'm sure you remember, we need to, because we're gonna run this program now, so we need to exit in a clean way. So I'm just gonna write RTS to quit this program. Because if I didn't do that, as I said before, then the code would just continue on here, and then it would start executing whatever is in my table and interpret those numbers as code. So I'm just gonna exit my code by writing RTS. Alright, load X to 0, load whatever is in position 0 in my table, store that in the memory address D020, the border color. Alright, let me save this and let me try to run this. Alright, so now I have a yellow border. Why is the border yellow? Well, let's take a look. So I loaded X with 0. Okay. Then I said load A with my table comma X. So this is the first position in my table, because 0, that's the first position. So we're storing whatever is in that position in the address for the border color. So what's in the first position? Well, my table, that's a 7. Well, I actually happen to know that number 7, that's the color code for yellow for the Commodore 64. which means that this is exactly what I expected to happen. A yellow border because the first value in my table was a 0. The color yellow for the Commodore 64. Alright, so let's just do one more experiment. What if I load X with 1? Well, do you remember what color the color code 1 is? Well, we're going to find out right now. So, color code 1, that's white on the Commodore 64. So I loaded X with 1 and loaded A with my table, comma X, which is 1 now. So my table, we have position 0, position 1, and there's a number 1 in there. Number 1, and that's white. So let me just do one more. Let's do the next one as well. So this time I'm going to load X with number 2, which should be 0, 1, 2. That's number 5. So now we're going to find out what color code code 5 is on the Commodore 64. That's green. All right. So hopefully that makes sense. It's just a table, and as I said, just like with the variables, every entry is one address in memory. So this table takes up 5 bytes. And by using the X register, we can get whatever offset we want in our table, whatever address in our table. And remember, we're starting to count from 0. So the first position in my table, the first entry in my table, that's 0. 0, 1, 2, 3, 4. Alright. Now, why did I mention the Y register? Well, the thing is, we could use the X register or we could use the Y register. So I could do exactly the same with the Y register. So instead of LDX, I could write LDY. But of course, then I would have to change this as well. So the X and the Y register, they can be used in this way to help the accumulator in cases like this. So by loading the X or the Y register, we could get an offset in a table. So just for fun, let me load next to last value here. 0, 1, 2, 3. I'm going to load Y with the number 3. And that's going to be 0, 1, 2, 3. So it's going to give us the color code, the color for whatever color code 4 is. Load Y with 3. Load A with my table, comma Y. Store the result in the border color. Alright, so let's see. Okay, so color code 4, that's purple. Alright, so that's tables. I don't think we need to go any deeper into this. Let's just keep it simple. So working with tables, the accumulator needs a little help from the X or the Y register. Which one you choose really doesn't matter. If you choose the X register or the Y register, they both work the same way in this case. Now there is a special case where we need to use only the Y register, but we're going to come back to that. But as I said, the point here is that making a table is really simple. And we load the accumulator with whatever value is in that table, with the offset, whatever is in the X or the Y register. But can we store anything into a table? Yeah, we can store anything. So let's forget about this border color for now. So what I'm going to do now, I'm going to say load y with 0. Then I'm going to say load a with the number 90. Actually, let me load a with let me just say 7. So I'm gonna load y with the y register with 0. I'm gonna load 7 into the accumulator. Then I'm going to store whatever's in A. I'm going to store that in my table, comma y, which means that now I'm going to store whatever is in A. I'm going to store that in my table at the y position. What's the y position right now? Well, it's 0. So that means that I'm going to store the number 7 right here. Well, that really didn't make much sense. We already have 7 there, but let's say I wanted to store the number 2 instead. So now I'm going to overwrite whatever is in the first entry with the number 2. So load y with whatever number we want from our table, and load a value into A, store that in my table, but at this offset. So in this case, that's this one, the first entry. All right. So hopefully that made sense. As I said, let's not go deeper into this. Let's keep it simple. But this is how tables work when programming in assembly language. So I think that's enough for today, and I'll see you tomorrow. Bye bye.